Welcome everyone. This is the EasyPower Thursday webinar series. Today we have a guest presenter who will be talking on the short circuit and protection coordination study in an actual industrial project. And I am your host, Jim Chastain. I will be assisting with the presentation. For those of you that haven't attended a webinar before, please use the question block in the webinar controls to ask a question. And those of you that are attending today will receive an email notice when the recorded video is posted to the EasyPower website. And all attendees will receive a certificate of attendance via email, so you don't need to do anything additional other than enjoy. And as we're in the habit of doing, we'd like to start with a couple poll questions. No liability or obligation, strictly trying to get some perspective of the audience's status. The first question, how often do you include equipment duty reports in an ARC? Well, I take that back. I even got my questions mixed up. How many ARC studies do you typically do a year? So I apologize. There's no obligation or liability. Strictly just trying to get some feedback from the audience as everyone's settling in. We're about 10 seconds from a quorum, so make sure you respond. Thank you. Here's how folks have weighed in. Looks like the majority are less than 25, which is fine. And then the next question is, how frequently do you have to coordinate systems with multiple relays? This is one of the aspects of the project that intrigued me the most. So I was curious what the status of the audience's activity has been on this. Again, we appreciate your attendance today. As I mentioned, we will be posting the recorded video on the website. It usually takes about a week or so to get it up and running. All right, so it looks like we have a quorum there. And I'm a little surprised that the majority does have multiple relays that you have to deal with. So I'm glad I asked the question. So 6 or 8 weeks ago, for those of you that don't know, EasyPower offers new EasyPower users what we call a Power Start, which is a 1-hour session to walk through your first project and ensure that you have a handle on the mechanics of the tool. It's not so much an engineering assist, it's more just make sure you've got the right buttons set as you're using the tools. I had feedback from an engineer. He said, Jim, I'm a new EasyPower user and I'm curious about this Power Start, but I've looked at your webinars and you don't have much supporting the market in Spanish, and all your examples are too easy. I said, yes, you're right. What about it? He says, well, I have a real project that I want to use EasyPower on, and I need a Power Start. So my response was, excellent, that's a good idea. And by the way, can we do a webinar using your project? And so he agreed to do that, and that's what spawned. We 2 weeks ago presented this material in Spanish, and today we're doing the English version of it. So I'm excited to have our guest speaker today. Herman Padilla is an electrical engineer with 17 years experience performing engineering design, construction, and related duties for oil and gas and mining industries in both greenfield and brownfield areas. Currently, he's employed in, as electrical project engineer at Wood PLC, Columbia. So with that, I'd like to turn the controls over to Herman. Give me just a second. Herman, you can share your screen now.
Okay, thanks, Jim. I'm sharing my screen. Can you see it?
Yes, looks excellent.
Yeah, yes, excellent. Thanks, Jim. Hello, everybody. It's a pleasure for me being here. First of all, I would like to say that I'm not very good at English, so please I apologize if I have any mistake or something like that. But I'm very glad of being with all of you because, as Jim said, a few weeks ago, or more or less a few months ago, I contacted him asking for support, asking for some specific question about how to use EasyPower, and the answer was excellent. We are working together in order to deal with a specific question of how I can use the software in my particular project. So I'm keen to share the way we are working on EasyPower on my project, right? So for that reason, this time we made the same presentation 2 weeks ago in Spanish. I'm better at the Spanish rather than English, of course. I'm from Colombia. I'm living nowadays here in Bogota. So let's start because time flies. So basically the topics we would like to talk today are, first of all, recommendation. Jim already talked about that. I would like to talk about my project, the specific parameters of my project. Most of you guys know about how to deal with EasyPower. Nevertheless, some guys are new with the software, so I just want to talk about my experience using the first configuration of EasyPower, first steps, and then let's talk about the short circuit study I've made using EasyPower and the protection coordination study. That's it. So I will be in PowerPoint and swap to EasyPower and come back. So let's start. Okay. So it's very important to let you know that I just want to explain how I've been using the software. All right. I don't want to deep with the details of the different standards of the short circuit or the relay coordination because time is not enough. I mean, here is to let you know how we have been working in dealing with the software and main aspect of my project. Okay. Nevertheless, at the end, all of you have my contact details. I have the same of Jim, his contact details. So you can contact us if you have any other question. And Jim, remember, feel free to interrupt me if you want to add or if you want to go with something else, right?
I will do that.
Let's start with, okay, nice. Let's start with my project. So basically, I'm talking about an oil and gas project. We have been using the latest version of EasyPower. In my scope of work with my client, we have to work with low flows, short circuit analysis, protection coordination, R-flash, harmonics, and stability. So basically, I have to use EasyPower in all our electrical studies. My project or our project, it's in Alaska, oil and gas. It's an off-grid project, so we have on-site generation. We are not connected to the grid. So it's the power system. We have different voltage level from medium voltage till low voltage. Our basis of designs are some client specification and all American standards. This project is very interesting because the geographical location, so the electrical system is strong, is redundant, so it's a nice challenge. It's a big challenge. Typical loads of this kind of project. So basically we have low voltage motors, medium voltage with VFD, variable frequency drivers. We have a lot of heat tracing, and we have other loads like panels, UPS, lighting, and so on. In this project, I mean, it's not for everybody, for all kind of project, but in this kind of project, we usually simulate different scenarios. In this case, we have 3. The first scenario is base case or summer case. The low lease are for that period of time during the year, so we don't have too much heat tracing, for instance. The other scenario we have model, it's winter. In winter, of course, a lot of heat tracing. So most of our low lease it's bigger in winter. And the last scenario we have, it's emergency. In emergency, our low lease, it's with only the relevant load. Our main source, which is a gas turbine, in the emergency case, it's off, and we have a diesel generator, which is smaller. And we have modeled a fourth scenario, but this is not real. This is only for the short circuit study. In that scenario, we have some particular settings to know or to get a higher short circuit current. Okay, so we have this in all these cases in EasyPower. So we have a look at each one. So this is our one-line diagram. I'm sharing this in PowerPoint before going to the EasyPower, just to have a general idea. So basically, in the project we are working on, we have some generation equipment here, right? Gas turbine, diesel generators. We generate at 13.8 kilovolts, and we have a lot of switch gears. So basically, lot of power transformers which step up or step down the energy from 13.8 to 480, for instance, to have low voltage. And we have two power transformers here to step up the power from 13.8 to 34.5 kV. So we have a lot of distribution in 34.5 kV. So, and in 34.5, we get till different areas of the project. And in each of those areas, we step down to low voltage. So we have a lot of power transformer, 34.5 kV to 480 volts, all of these. And we have a switch gear as well in medium voltage. We have one of 1.16 kilovolts for some medium voltage motors, right? So we have some power transformer which is step down from 34.5 to 4.16. So it's a very interesting project here. So we have a lot of electrical equipment. So we will see on the EasyPower model. So EasyPower configuration. When I'm working on EasyPower from this year, right? So at the beginning, I've started seeing all the gym webinars and on live webinars on Thursdays and videos on YouTube, right? At the beginning, I used that information to make my model, and the support of some of my colleagues here in Colombia, people who work on Wood, the company I'm working on. So they were familiar with the software, so they support me at the beginning. And I started with the general criteria, how to start with equipment modeling, copy-paste equipment attributes, which is something really nice, the equipment database, all the scenarios, and the load grouping. We will have that. So let's move to EasyPower. I will share my EasyPower project. Can you see, right? Yes, Jim?
Looks good.
Yeah, excellent. Yeah, nice. Basically, this is the one line we have in PowerPoint. So just to go about the general parameters, the basic parameters, which I think is useful at the beginning when you are getting familiar with the software. So for instance, here in file, something very, very useful, the library. So we have the library here, so we can go through the library. We can work on some parameters regarding, for instance, our flash. I was working on that. We have here as well, for instance, the contact support, something very, very important at the beginning when you are getting familiar with the software. So I have here the information to send any question to the guys from EasyPower. Something very useful as well, the database. So from this button, I have the information. I can have a look at all equipments we have modeled. So buses, MCCs, power transformers, relays, CTs. For instance, here in relays, so I will show you. We have been modeled all relays we have in the electrical power system, or the power system, to make the relay coordination, right? So here we have all that information and so on. So I think that this database is very useful to have an idea about how we have modeled, and if we have to check any particular settings of each equipment, is easier doing on that way. However, we have find and select, something which I think is very useful as well. In this button, we have the scenarios. So at the beginning, we made the base scenario. We model everything in the base scenario. We are in the base scenario right now, base case. And after that, we create new scenarios. It's very simple. And after creating new scenarios, we went through each of those scenarios, and we made the different changes. For instance, if we have a look at this one, base scenarios and winter scenarios, the gas turbine is connected and genset diesel generators and off. So when we would like to have a look at the short circuit, standby scenario, we see that one of the changes we have in that scenario, that gas turbine, it's open, one diesel genset, it's open, and we have only diesel genset. Why all these kind of parameters, and why these or not, it depends on each project, right? When we are at the beginning working with the client, arranging everything, we define that parameters. Okay, something which I think it is useful as well. This tool. I come back to base case. So remember, we work on the base case, and if I have other scenarios, I create those scenarios, and on each of those scenarios, I make the specific changes. Usually it's open or close, breakers, something like that. In this project, everything is redundant. So we have type breakers, we have switch gears or MCCs, bus A, bus B, and each of these two buses are connected by a type breaker, and each power transformer, it's capable to feed 100% of the loads down, right? So usually something we have in our model, it's one incomer open and tiebreaker close. This is the philosophy we are modeling. Okay. I said that. Sorry. Go on.
I got a question. So I noticed that you use resistor neutral grounds on your transformers. Yes. What's the reason for that, or what was the justification for doing that?
Yes. I will show you something very interesting about that, because I was working on that recently. Basically, Jim, we connect grounding resistor to decrease the short circuit current. Okay.
Mm-hmm.
This is the main reason. Usually when we have medium voltage transformers, it's more common in medium voltage to use in the secondary side grounding resistor to decrease the short circuit current, right? In this project, we have grounding resistor in all power transformers and in all generators. But in other projects, I include usually only grounding resistors in medium voltage transformer. I mean, from 34.5 to 1.16 kV. But in this case, our current neutral grounding resistor are everywhere. I will show you something, just an example, because I was dealing on that this week. For instance, this power transformer, when I was modeling this at the beginning, I include this grounding resistor, 5 amps. So then we said, okay, we're going to buy a 400 amps grounding resistor, but 400 amps grounding resistor, it's a good size. Let's have a look. So this is something. This is an example. How I can confirm this the best size of the grounding resistor. It doesn't matter the size I've chosen before. It doesn't matter. So I go through the short circuit and I made the calculation. I will talk a little bit more about the short circuit study then, but this is just an example. So basically, I have short circuit, let's half cycle, ground, line to ground fault, and I have a look, and we have 45 amps. 45 amps is the current in a fault in this part. So maybe a 400 amps grounding resistor is too big. Maybe only with a 100 amps grounding resistor we will be able to deal with this short circuit current. Okay.
Mm-hmm. Nice.
Yes. So let's come back. So I will say about copying and copy and paste attributes. For instance, when I was modeling all relays, so I realized that this function is very useful. Copy. So I work on each of these relays. So I had to go here. I have to select the manufacturer, the type of relay, all this kind of information. And after setting this relay, it was simple for me copy and paste on all other relays. Sometimes that is not possible. Here is possible. So I took advantage of that. Okay, so basically the general settings of EasyPower is that. So let's come back to the presentation. We talk about the short circuit calculation. So basically in this project, like in other projects, our object to do that is to calculate the maximum fault current in the electrical system or in the power system. With that calculation, we can select properly the nominal values of panels, switchgears, MCCs, breakers, right? No. So this kind of a study is very common in most of the projects. With that information as well, we can work on the relay coordination. Okay, so the assumption made in this short circuit study, I remember that the assumption made here is for this particular project. In other, can be different. Okay, so in this project, we are using the wine line, the load list, cable schedule, all that information from the project, right? We made in Excel, in other software. We use as input for this study. We made our main power source is the power gas turbine. Remember, this is a off-grid project, so we don't have the grid. An assumption we made in this project, all power transformers were modeled with a tap of -5%. This means that the impedance of each power transformer is slower, therefore the short circuit current is higher. So in this, we include all these assumptions in the short circuit case. Only the short circuit case, we include all these assumptions in order to have the worst scenario. The worst scenario to have the highest possible short circuit current, right? Other assumption we have made in this scenario for this particular project, all motors are assumed to be operating. In real life, it's not that, but as I said before, we are looking for the worst scenario. We have used libraries in EasyPower to have the information from cables, motors, and so on. For instance, something very useful, we have used in EasyPower or using EasyPower the information for the harmonics contents or different loads, the harmonic contents on different loads. We have used from information from the library in EasyPower, and we were able to modify the harmonic context on some loads as well. And as I said, switchgears and MCC, all tie breakers are closed. We have only one incomer open. Remember, if we have both incoming breakers closed and tie breaker closed, the short circuit it's twice because the power transformer are in parallel, therefore the impedance is in parallel. So this scenario is not possible. It's too high, right? So all breakers or zone of incoming breakers are open with the tie breaker closed. Those are the assumptions for this particular project. So in EasyPower, so we will come back to EasyPower. In EasyPower, we learned all the study options, the calculation options for the short circuit, half cycle, 30 cycle, the short circuit 3-phase, ground, 2 lines to ground, so on. We were working on equipment duty as well. We learned how to work with the remote voltage and current and reports and something about the R flash. So we in our EasyPower report, we include all of this information we got from EasyPower. This is some, for instance, a picture of the results. In our results, we have everything in green. It means that the nominal size of all equipments are okay according to the different short circuit we have in the power model. And this is a report as well. This is a typical report we got from EasyPower. Now we will see how we can have this in the software. But basically, we model everything. We set up the study, and then we make calculation. We export the report. We work in the report in Word, and we attach all these reports from EasyPower in our documents to support all our calculation and our conclusion and results. Okay, so let's come back to EasyPower. So basically, as I said, when we will work on the short circuit calculation, so usually, or I had to go to the short circuit scenario, right? And it's simple short circuit. Here we have the short circuit report options. So this is, I mean, it's very useful, all videos on internet about how we can deal with EasyPower, because these settings usually don't change between each project. I mean, more or less are same here. And this is regarding the short circuit reports, short circuit options. So the information we would like to see in the one-line diagrams, all of this is pretty similar in all projects. And the outputs, I mean, it doesn't change too much. We can go on our flash hazard. So here we can select the standard, right? This is something we were working with Jean according to how we can get the R flash calculation in the correct way. So about we were working to understand this, excluding main, including main. That's it. All of this information is on the internet as well. And we were working on that, the spreadsheet, the threshold, the different units. And in the advance, we were able as well to select the different standards to calculate distance, PPEs, and so on. So I mean, it was very useful having a look at all the different videos on the internet in order to set in all these kind of options. Okay, so to cancel and basically here, after working on the option and reports, we go just to calculate the short circuit. Okay, it takes time, but at the end we have results. So we can go here, for instance, to have a look at the different reports. We have the reports of each of bus. We can see as well we have low voltage, high voltage for momentary current, for interrupting current. Let's check, for instance, something very important to remember. This scenario, it's the worst case. So when we would like to have a look at, for instance, at R flash, so we have to swap to the winter scenario or the base scenario. And something which is very, very useful, it's create a scenario comparison report, right? So we can, let's have a look at add flash, add chain, yes. So I didn't know at the beginning about this function. If, for instance, and I have three different scenarios, right? Base case, winter, and emergency. I would like to know the R flash. So something useful is to compare the results of each of those three scenarios and to select the number with the highest current. Okay, so we can do that. And new group, let's have a look. Create a report. Okay. For instance, I've select in this comparison only some buses, only some MCCs, right? I select as well the three scenarios, all except the short circuit, which is not real. And here I can see, for instance, in this MCC, in which scenario we have the worst case, which is this one, right? So here we have the information for the alt flash of this scenario. So with that, we can go to print the labels for the worst scenario, which is something very useful because these MCCs, this MCC is working on each of these scenarios, but in winter it's the worst because in winter it has the highest load. Okay, and using this option we can compare and we can say, okay, let's see only the worst scenario. So basically for this panels, the worst scenario is winter, and these are the numbers for the short circuit for the R flash calculation. And with this, we can go to the print label to print label. So worst scenario for all buses. This. So when I was working on the R flash study, I learned how to edit the labels. It's in some videos, Jean explained how we can add pictures, how we can modify. I mean, at the end, there are a lot of options for labels, but you can use any option you want, and you can make specific changes to be able to customize your label for your project. So this is very, very useful, this option of comparison of scenarios. We can use that option as well for the another option for the equipment duty. So equipment duty. Let's have a look at the equipment duty. So basically, I select short circuit. I just want to select one bus if I don't want to spend time with all of buses, and I make the short circuit calculation. Okay, and I have a look at equipment duty here. This is the button for equipment duty. This is the button for R flash. These are the buttons for half cycle, 5 cycles, 30 cycles. These are all the buttons for the short circuit calculation. Okay, equipment duty. So here I have the information of my short circuit current, and I have as well the nominal size of my equipment. So these are the number of the current, and these are my nominal data. So it seems like this bus is strong enough to support the short circuit calculation. Another very useful function we have is the remote voltage and current. So I select. Sorry.
That would just be for a single bus.
Yes. Okay, for a single bus, I select this one. Yes, because this function it's only for one bus at a time. Okay, but something we have to select this. Always we have to select this. We select the bus. We select here, and we make the voltage. So we can have a look here. Oh, sorry. Again, so we made the short circuit calculation. We select here, and we can have a look at the report. Hard flash, high voltage.
It'll be on the one line, Herman. remote voltage and current. Just scroll in.
Yep.
Yeah, scroll in further.
Okay. Okay. Our flash. Why, Jim? I can't see the remote voltage and current.
Yeah, just scroll in. It's going to be finer print. If you need to zoom in a little bit. Sorry.
Okay. Yes.
Fault that bus.
I fold that bus.
And click on remote voltage.
Okay. Okay. We see. Okay, and we can have a look at here. We can have a look at, for instance, this one. So in this report, we have all the branch contributions of that in that bus. Okay. So to have the report of the short circuit study is from here, right? We can for instance to have the usually we fold all buses at a time. Okay, and after that I go here and I'm just import in PDF, right? And from this report I made my final document. Regarding our flash, I select here to make the R flash calculation. So we realize that we still have some buses in red. It means like we have still some high numbers here. So it's something we have to deal with. Okay. And other are okay, are green. And we can have a look here at the R flash hazard report. So we can edit the columns, we can add, include, right? We can have a lot of changes on this report, and after that we can just print on PDF to add as attachment in our final R flash document. Okay.
Herman, question.
Yes, sir.
Robert observed, did you calculate arc flash incident energy while in the emergency mode when you were doing your comparison?
Yes, in the emergency as well. Let's have a look at the emergency scenario. In the emergency scenario, standby scenario, we can see loads we have connected. Most of those loads are off in the emergency scenario. So when in my document, how I did in my document, in my flash document, I made the all calculations of, I calculate all buses in all three scenarios, but in some scenarios like this, for instance, in emergency, so I'm not using the information of this switchgear because in this scenario, this switchgear is off.
Right.
Okay.
Okay.
Okay. Let's move again to the base case. Good. Okay. So, regarding the short circuit, Jim, what else do you think is useful to share?
I think you did a pretty good job.
Okay. So let's move forward to the relay coordination study. I apologize because an hour is not enough, but we were able at least to show you all the different functions EasyPower has. Okay, so the report, and let's talk about protection coordination study or relay coordination study. So basically the same object you usually have to do in other projects to get all settings for the relays in order to have an adequate behavior for a short circuit faults, in order to have an according operation sequence, declaring the fault, selectivity without compromising the integrity of the system. The object is the same you usually have in your project, nothing special. The assumption we have made for this study it's different to the short circuit. So here we work on the normal cases, winter, base case, and emergency. But we have to remember that the settings of relays have to be able for all three scenarios, right? We can't change settings in each of those scenarios. We have to get the settings which works on all of them. So the assumption, basically the same of short circuit. For instance, the information, the input information is the same from the project, load list, cable list, and so on. The main power source is power gas turbine. The transformer were modeled with taps according to low flow. I mean, in our low flow, we got one of the results was the taps for each power transformer, and we are using all libraries in EasyPower, including the information from relays as well. And the same, all type breaker are closed, so one incoming breaker is open. So after setting the project or each scenarios for the coordination study, so we went through the option of the study. We were working on the relays and their functions. We learned about the TCCs, current versus time curves, the protection sums, the sequence of events, which is something very, very useful. We include in our report, thanks to EasyPower, to explain different example and how for each example we can see how each relay steps upwards works. I mean, maybe we will have an example and reports and something about the R flash. So let's go to EasyPower. But before, let's have a look at the results we got from EasyPower. For instance, some TCCs, right, with the curves of relays, of breakers, of transformers, of power cables, and the one line. So in EasyPower, we got these curves, and in our report, we include all these curves in our attachment of the final coordination study report, right? And we include as well all the settings of the relay. So in the coordination study report, we are able to export using PDF all the settings of the relays and breakers to be included in our coordination study. Okay, so let's come back to EasyPower. So basically, so we have this case, this scenario. So we select the coordination study, and we can have a look here and the different options of the report. So, sorry, this is the result. This is the report. Here, for instance, we have all the information on our relays, the settings, everything is here. So I export this in PDF to my document. Okay, so I got this table. Let's continue. Something very useful I will let you know. Well, okay, right now, before forgetting, here as well we can configure the report. We can include, we can cut columns. I mean, we can manage this as we want in order to include the information we require. Okay. For instance, this is a configuration report. This is a report 1, which was modified by me in order to include information I would like to show. Okay, and in the coordination study here we have the coordination option. So basically we can work with the general option. Usually I didn't make too many changes of this. Here I made some slightly changes. This is to make things better to be seen. So after that, we made the coordination. So basically, how I work on that, I select, for instance, this branch, and I went to plot TCC. So at the beginning, I got this, and I had to arrange everything. So, for instance, cancel the one line here, add or include the title block, and working on that. I was able to get this kind of TCCs. Let's open one TCC, for instance. This, I've saved all TCCs. Then I export to my report. This one, for instance. This TCC belongs to all these parts. So here we have basically two different zones. So we have this MCC here, this MCC here. So I have the all TCCs, right? So I am always, it takes a little bit time because you have to arrange everything, you have to configure. Of course, you have to settings, you have to click on each of these relays, for instance, and make the different changes here in settings, and confirm and revise and check and everything. I mean, it takes time, but at the end you can get a nice results. And yes, sir.
Here's a question. Did you use or did you find Smart PDC useful? Did you use Smart PDC?
This, I mean, Jim, frankly speaking, I've seen in your video that it's very, very useful, but I don't have that function available. If you see.
So you did it all by hand. Good for you.
Yes, it seems like I had to learn more, because it seems like when you explain Smart PDC, things work perfectly. I mean, like you don't have to think too much, but when you don't have, you have to take care more. Yes, Jim. I don't have it, so.
So how was sequence of events for that purpose?
Yes, let's have a look at sequence of events. So for instance, here in these medium voltage motors, so we can check here. So I select this bus, and I can, I said, okay, let's check a fault here. I select here, and let's have a look. I had to select this. And I see how, if I have a fault here, I see how the current goes. So pass through this relay, type breaker, this, because this incoming is open, and go up to here, and finish on the gas turbine. So we see that all our relays are green. It means like the sequence of events is correct. So let's confirm using the report sequence of events. So this is very useful. We can simulate a fault everywhere, and we can select the sequence of events, and we can see how is the sequence, how is work each protection upstairs, and the times, and so on. So we can make, for instance, I made sequence of event on all three different cases in order to confirm that in all cases the sequence of event is correct. Therefore, the settings of each relay, it's okay. Okay, this is something very nice about sequence of event. Let's have a look at something, Jim, which I think is very useful as well, is regarding our flash. Here I have an example, a good example. For instance, in this MCC, the R flash, if I have a look here, I choose, it's too high, this one, and this one, and this one, okay. R flash, here. Okay, sequence of events, okay, wait, okay, sometimes, okay, here I have to work, this project I'm working on, we have to work on the protection upstairs in order to decrease the quantity of calories per square centimeters, okay, but sometimes which is very, very useful. For instance, if here we have a height R flash, we can work with this in this way. Plot TCC, and we can see if maybe the arcing current it's not seen by the breaker. So let's have a look. Here it seems like, I mean, the quantity of calories it's good. So it means like when we check here, insert, this is a very useful function. Jim told me about that. Insert arcing current. Sometimes in some cases the breaker, I mean, when I'm working on relay coordination, the breaker is okay, but the arcing current is seen by the breaker in long time. So with this function, we plot the function, and we can as well move the TCC of the breaker of this one in order to improve the R flash, right? I mean, I didn't know about this function. I've learned a few weeks ago, and I'm checking on all MCCs if I can improve the result of the R current doing that, working on the breaker, on the TCC of the breaker, to confirm that maybe I can improve the TCC to get a better result of the R flash. Okay. Okay. Regarding the relay coordination, Jim, what else do you think is very useful to share? Which other function we have been working on?
Well, so this was a personal, I guess, point for me. When you set up your arc flash conditions, you didn't limit the max time to 2 seconds like a lot of people do? Do you remember why we left that at 200?
Yes. For instance, when we have a look here, our flash hazard, advanced. Here, max time. Yes, it's 2, but I include 200, but yes, the idea is to use here only 2 seconds, right?
Well, but that's after you complete the coordination, because setting that prematurely will obscure that coordination issue you just looked at.
Yes, sorry. At the beginning, I had 2 seconds because I saw once 2 seconds, but it's 200 because if we left here 2, our results are not completely correct, right?
Right, exactly.
Right. Yes, exactly. So yes, at the beginning in the R flash, I put this a restriction here of 2 seconds. Of course, the results were really good, but we realized that 2 seconds wasn't real because the relay coordination, they sometimes they don't operate at 2 seconds. It takes longer. So 2 seconds, 200 seconds, it's better, right? Because we take into account the relay coordination.
Exactly.
And we the 200 seconds. Yes, Ian, that's correct. So basically, I think that as these are most important settings function we have used in EasyPower. So I think that this as I said before, now working on the stability study. So this is very, very useful, and there are a lot of things to learn about the stability study using EasyPower.
So Armand, roughly how many TCCs did you save?
Okay. So far, I have more or less like 30 TCCs. Yes, because I have some. If we have a look quickly, I have, for instance, simple TCCs. I have open. I have, and something like that. I have a lot of TCCs. Yeah. Yes, I try to work on, for instance, to select this part, only this part. Then I select also this part in order to make the different zones, right?
Yeah, so that's what I was asking, is how do you enforce the zone philosophy?
Yes, and that's it. I don't know, Gene, anyway, you think that if we have more questions, we can work on that question to give everybody the answer. And as I said, these are my contact details, because it's amazing how time flies when we talk about these topics.
Yeah. So Alan has a question. Can you show again how you inserted the arcing current?
Yes. Okay. The arcing current. Let's have a look at this, for instance. Let's see the arcing current of these 3.
Put the breaker in at the top.
Okay, we have 5i. It seemed like now it's okay. But how we can see the arcing current?
You plot the TCC.
We select this and I plot the TCC. Okay, and I hide this to bigger the TCC. We check the MCC, the arc flash of this. It's not bad. So in order to have a look at the arcing current, right click on the breaker TCC, and we have insert arcing current tick mark, and it's here. For that reason, the arc flash is good because the time, I mean, the breaker is seeing this current, so it operates very quickly if there is an arc flash. But sometimes the breaker is like this tick. I mean, the arcing, you don't see the arcing current, you don't see this because it's off, and you don't realize. So a nice way to improve the results: insert arcing current mark. You insert.
So Alexander's saying, how is the 2-second rule adversely affect coordination?
Yes, Jim. Please, because from my point of view, the 2-second doesn't affect coordination, right?
Right. It obscures it. It doesn't. It's allowed by the standard to limit the max time for arc flash calculation, but if you do it prematurely, then you obscure exactly that conflict you find with the arcing current. So the incident energy on this was artificially low because of the 2-second max. So now that if you go back and change your 200 seconds down to 2 seconds, you'll get a more realistic result because only the low voltage issues will be limited to the max time. Does that make sense? Alexander, did that make sense?
Yeah.
Herman, you did a great job. Looks like, so there's a question maybe you can better understand than I. Omer's asking, does EasyPower create RDB files for SEL relays? I'm not sure what RDB file is.
Well, frankly speaking, I don't know. We have a look of the settings and the report. This is the report. So I'm not sure if from EasyPower we can get the report to feed the relay directly. I don't know.
Okay.
I don't know.
No. The answer is no. That's
okay.
I understand.
No. Okay. Yeah.
All
so
right.
basically, the guy who will set up the physical relay has to use this table.
Correct.
And include information manually, or maybe export, because maybe we can export this not only to PDF, we can use Excel, and from Excel, maybe it's easier to change to a kind of document which the relay can import.
Right.
Maybe.
The only other thing that was really fascinating about this project was the use of the G&W relay and
yes, we're working on this. Yes, we're working on this. Yes, why? We have other medium voltage switchgears with this brand. I understand that I haven't worked with this before, but it seems like this is very, very strong kind of switchgear, which can be used outside, underwater. I mean, with a very, very strong situations. So this equipment we here in medium voltage, as you see, the incoming and feeders don't have relay. But please, Jean, explain this electrical and electronic part, which is very interesting.
Well, we do need to put a relay in there, but it's a G&W special relay that can simulate a fuse or a relay. And so what the design papers indicated was we want to use the TCC curves for fuses that the controller will simulate. So that
this one, for instance.
Yeah, exactly. And that was fascinating. So
we can,
for the audience purpose, I'm trying to work with the G&W folks to see if we can do a presentation on that type of equipment on one of the Thursday webinars. Yes.
Nice.
Exactly.
It's very sophisticated. But anyways, it's nice. We have lot of job to do, but we're working on, and thanks Jim for your support. I'm keen to be here, and I hope to continue working. And I remember, if someone has any particular question, you have my contact details.
Thank you, Herman. It's an excellent job. I don't see any other questions come in, but certainly we have room for you. Here's a question from Dinesh. Why was the SAL relay family selected for use? Why did they choose Schweitzer as the supplier for the relays?
Why?
Yeah.
It's a good question, but I don't have the answer. It seems like the client familiar with this brand, because all our relays belong to this brand. Yes, but when that was like an input given by the client, say, okay, let's work with this type of relays.
As we all know, the customer's always right, so you don't argue.
Yes, exactly. And here in our electrical department, we select the type of those relays. We have different kind of relays, 751. From the genset, we have another one, 700. We have different relays here, a lot of different families, but all belongs to the same brand. Okay, yeah. I mean, we have a lot of things to do with these relays. I hope to learn more, because it's not easy to have relays, medium voltage, low voltage, but I hope to do in this project. Okay.
Well, thank you very much, Herman. It was an excellent job. And we look forward to maybe having you as a presenter someplace down the road.
You're welcome, Dean. Thanks all for your time, and nice to meet you all. Thank you very much.
So long.